Method number 4 is the use of integrating factors. Now, we will use this method, that is the method of integrating factors, when we solve differential equations of this form. Okay, dy dx plus py equals to q, where p and q are functions of x, or they may be constants. Okay, so we will use the method of integrating factors when we recognize the differential equation of this form, dy dx plus py equals to q, where p and q are functions of x. Okay, now we will multiply both sides of the given differential equation by the integrating factor. I will use if for integrating factor, and the integrating factor is given by, okay, e to the power of the integral of p dx. Okay, not difficult. So we're going to learn the concept by looking at this example. So let's follow this line by line. We are asked to solve dy dx minus y equals to x. So first thing, we want to write what is p. So p is -1 and q is x. Now we want to find the integrating factor, which is e to the power of the integral of p dx. So I've done that. E to the power of the integral of minus dx, you will get e to the power of minus x. Now we have to multiply both sides of the differential equation given to us by the integrating factor, and that's what you can follow in this line. E to the power of minus x dy dx minus y times e to the power of minus x equals x times e to the power of minus x. Now look at the left hand side. You can get the left hand side when you differentiate e to the power of minus x times y. Okay, I'll repeat. Look at the left hand side. Yeah? You can get the left hand side when you differentiate e to the power of minus x times y with respect to x. Okay, write down the first term, differentiate y, you will get dy dx. Write down y, and then you have to go ahead and differentiate e to the power of minus x, you will get minus e to the power of minus x. So the left hand side is what you get when you differentiate this, so we can write it as d over dx e to the power of minus x y, and the right hand side is of course x e to the power of minus x. So let's bring the dx up. Okay, if we bring the dx up, we can write our line as e to the power of minus xy equals the integral of x e to the power of minus x dx. Okay, so what's left is the right hand side contains an integral, so we have to go ahead and integrate. This one we are going to use the by parts method, which we have learned before. Okay, we are using the formula u dv equals to uv minus v du. So I have done the steps for you. I've used u equals to x and dv equals to x, dv equals to e to the power of minus x dx. Okay, now use the by parts idea and arrive at the integral of x e to the power of minus x. Okay, not difficult. Yeah, this one here, u is x, so du is dx. dv is e to the power of minus x dx, so v is minus e to the power of minus x. So use the formula and arrive at the correct answer. So integrating x e to the power of minus x dx, we get minus x e to the power of minus x minus e to the power of minus x. Now we can write down the answer. On the left hand side we had e to the power of minus xy, so the right hand side now becomes minus x e to the power of minus x minus e to the power of minus x plus c. Okay, now what I've done is I've multiplied throughout by e to the power of x, so that my left hand side only has y. So I can write my answer down as y equals to minus x minus 1 plus c e to the power of x. Another way of looking at it is you divide throughout by e to the power of minus x, you'll still end up at the same answer. A couple of points to note when using this method. First, we have to find the integrating factor, okay, and once we have done that, we have to integrate what emerges on the right hand side. Yeah? As part of our working, we have to integrate what emerges on the right hand side. In our case, this is what came out on the right hand side, okay, x e to the power of minus x. So we have to integrate this. So essentially, these are the two things that we have done when we use the method of integrating factors. Looking through the previous example, what do we find? The IF method, the integrating factor method, only involves this line, which is y times the integrating factor equals the integral of q times the integrating factor dx. Okay, so when we want to use the integrating factor method, first step of course is to find the integrating factor, and the second step is to go ahead and use y times if equals the integral of q times if dx. Okay, solve and we are done. So let's look at another example. X dy dx plus y equals to x cubed. We are asked to solve x dy dx plus y equals to x cubed. So let's go ahead and rearrange the differential equation. Divide throughout by x, you will get dy dx plus 1 over x times y equals to x squared. Okay, so that we have it in the form dy dx plus py equals to q. Okay, remember we have dy dx plus py equals to q. So now this looks good. So we know that p is 1 over x, okay, and q is x squared. First step, we have to find the integrating factor, e to the power of the integral of p dx. When you do that, we are going to integrate 1 over x dx, so we will get e to the power of ln x. And we know from our previous courses that e to the power of ln x equals to x. So I know that my integrating factor equals to x. Take note of this. E to the power of ln fx equals fx. So using the idea y times if equals the integral of q times if dx, straight away we can write y times x, okay, equals the integral of q is what? X squared. If is x, so x squared times x dx. So let's follow line by line. Okay, the left hand side is xy, and the right hand side is the integral of x cubed, which is x to the power of 4 over 4, and we are done. Okay, don't forget to write the plus c on the right hand side. Next example. Okay, we are looking at solve dy dx plus y cotangent x equals to cos x. So straight away we can write p equals to cotangent x, q equals to cos x. So the integrating factor if is e to the power of the integral of p dx. Cotangent x is cos x over sin x. So when you do that, the integral of cos x over sin x dx, you know the answer is ln sin x. So we get e to the power of ln sin x, which is equals to sin x. So the integrating factor is sin x, and we are going to use y times if equals the integral of q times if dx. So we can write y sin x equals to the integral of cos x sin x dx. Now sin 2x equals 2 sin x cos x. So I've replaced sin x cos x with sin 2x divided by 2. That's what you see here. Okay, I've taken out the half. Okay, again let me write it here. Sin x cos x equals to sin 2x divided by 2. So now I can integrate sin 2x it is minus cos 2x divided by 2. So cleaning up the working, I have y sin x equals to minus 1 over 4 cos 2x plus c. Next example, we are asked to solve x dy dx plus 2y equals to cos x, x bigger than 0. Let's look at the solution line by line. Okay, we want to write it in the form dy dx plus py equals to q. So we divide throughout by x. You will get dy dx plus 2 over x y equals cos x over x. What have we done? We have divided throughout by x, so that we can write what is p, which is 2 over x, and we can write what is q, which is cos x over x. So first step, find the integrating factor, e to the power of the integral of p dx. When you do that, you will get the integral, when you do that, you will get e to the power of the integral of 2 over x dx, and you will find that the integral of 2 over x is 2 ln x, and we have e to the power of 2 ln x. Bring the 2 up, you will get e to the power of ln x squared. So e to the power of ln x squared is equals to x squared. Okay, we know the integrating factor is x squared. We can write the famous line now, y times if equals to the integral of q times if dx. So if is x squared, so y times x squared equals to q cos x over x times x squared dx. So the right hand side becomes the integral of x cos x dx. So this one is a simple integral for us. We can use by parts, and I have done that. Okay, when you use by parts, the right hand side becomes x sin x plus cos x. I'll repeat. Carry out integration by parts for this, and when you do that, you will get x sin x plus cos x. So now all that's left is for us to write down the answer. Don't forget the plus c. Okay, so on the left hand side we have yx squared equals x sin x plus cos x plus c. I've divided throughout by x squared and written my answer as x sin x plus cos x plus c, the whole thing over x squared.